Hey family, welcome back to Say Guru Academy. Today we're tackling question 2 on complex numbers. Let's break it down step by step. On question 2.1.1, they gave us a complex number and we are asked to write it in the simplest form. Remember, to write it in the simplest form, we need to write it in form of a plus bi, right? So the first thing I'm going to do here is I can see that, okay, here I'm going to multiply, right? So 1 over 5 times 5 will give us 1, right? And then 1 over 5 multiplied by negative 10i will give us negative 2i, right? Okay, and then, so far we have this, right? Let me just write the last part. We have I minus 2 at the bottom, okay? So ladies and gents, to simplify a fraction in complex numbers, we always multiply both the top and the bottom by the conjugate of the denominator. So the conjugate of the denominator is just, you switch the sign on I. You see I is positive here. So the sign here will be minus. Then the other part remains the same. So a conjugate of a complex number is just you going to be switching the sign on I and leave the other number, the real number, the same way it is. Then on top you do the same thing. Good. Remember, we multiply by the conjugate of the denominator, not the numerator. Okay, and then we have z equals to 1 minus 2i minus, if you check on top, it's going to be 1 times negative I. Okay, let's put a bracket here. For now, we're going to have this times that and this times that. So 1 times minus I is just minus I. Sorry, let's take it back to white. So here we have minus I. And then 1 times negative 2 is negative 2. And then now we're going to do the 3, right? So it's going to be negative 3i times negative I. That gives us, let's see, negative 3i times negative I, it's positive 3i squared. Negative 3i times negative 2 is going to be a positive 6i, right? That's going to be positive 6i, okay? And then let's check here. At the bottom, it's easy. Now, the first one will always multiply with the first one. And then the last one multiplies with the last one. The middle ones are always going to cancel. Now, when you multiply a complex number by its conjugate, just multiply the first term with the first, the last with the last. Right. Perfect. So here we're going to say minus I squared. Okay, I'm just going to multiply everything to show you. So minus 2i plus 2i, then plus 4. You can see, ladies and gents, that I said this times that gave me minus I squared. This times that gave me minus 2i. This times that gave me plus 2i. This times that gave me plus 4. All right. Now let's keep on simplifying this. The z is equals to 1 minus 2i minus, in bracket, if you check on the top, minus I plus 6i will add to give us positive 5i, right? They are like terms. Then we have minus 2 plus 3. I squared, remember, it's minus 1. All over negative I squared, which is minus 1. The middle terms will cancel here. So I have plus 4. Okay, let's keep on going. We have z equals to 1 minus 2i minus, in bracket, we're going to have 5i. If you check this part here, will give us minus 5, right? Because it's minus 2 minus 3. So that is minus 5. Then if you look at the bottom, we get a positive 5 because it's going to be positive 1 plus 4. So I'm going to divide this by positive 5 and that by positive 5. Okay, and we have z equals to 1 minus 2i minus in bracket I minus 1, because the 5's cancel, right? This 5 cancels that. Here you're left with minus 1. Then you have z equals to 1 minus 2i minus I plus 1, which is z equals to 2 minus 3i. Right. And that is z simplified because it's now in form of a plus bi. Okay. And then if you check here, the second question, 2.1.2, they want us to represent z in the Argand diagram. The Argand diagram. Remember, on the Argand diagram, we have this. This is the real part. The x-axis is the real part. This one is the imaginary part. Right? So we just have to plot a point. And the point that we have here, if you check, I said the x is the real part, the y is the imaginary part. So we have point 2 coordinate minus 3. Always remember we start with x then y. So I know that x2 is here, and then y minus 3 will be there. So the point is there. And then we do this. Then we just show that that point is what? Is 2 coordinate minus 3. And we have shown it in an Argand diagram. Right. Now let's go to the next question. 2.2.1. On 2.2.1, we are given that z1 is equals to 3 cis 25 and z2 equals to 2.9 cis 65. Then we are asked to multiply. We are asked to get z1 times z2. Remember, the rule for multiplication of z1 times z2 is the product of the r's. So r1, r2, we multiply the r's, and then c's, sum of the angles. You add the angles, you multiply the radius, right? So let's get let's put a substitution. Our r's are 3 times 2.9. Then c's, the first angle is 25 degrees. If we check there, the second one is 65 degrees. So plus 65 degrees. And then therefore z1 times z2 equals to 3 times 2.9 should give you 8.7 on your calculator. And then cis 25 plus 65 will be cis 90 degrees. And you have multiplied the polar form, right? Awesome. Then next question, 2.2.2. 2.2.2. We are given okay, let's just check 2.2.2. What are we given? Let's check. So we are given 3 cis 25. Oh, so it's the same question, but now we add in. Do we see it, ladies and gents? Okay. Yes, 2.2.2, we need z1 plus z2. Okay. We firstly need to convert each to rectangular form. Remember, rectangular form, it's a plus bi. So I'm going to convert z1 into the rectangular form. I have 3 cis 25 as z1. this is going to become, okay, let's just reduce this a little bit. It's going to be 3 into bracket cos 25 plus I, remember the C for cos, and then the I for imaginary, the C for sine, plus sine 25 degrees. And then Z1 would therefore become, if you say this times that on your calculator, it's going to give us 2.7189. I'll round off to 4 because this is not the final answer. And remember, we always round off our final answers to 3 decimal places. So if it's not final answer, round it to 4 or to 5 just to maintain the accuracy. Okay, and then we're going to say 3 times sine 25. So that will give us a 1,2679, but there's I there, so I have to write that I, right? So Z1 is now in rectangular form. Let's do the same for Z2. Z2 would be, if you remember, it was 2.9665, which means it's going to be 2.9 in bracket cos 65, and then plus I sine 65. So the C's just means cos of the angle plus I sine of the angle. Okay, sure. So now taking this and multiplying by that will give us a, let's see, on our calculator, that should give us 1.2256 plus taking it and multiplying with that 1 with sine, so 2.9 times sine 65 should give us 2.6282I, right? Now remember, this is Z2, no? So Z2 is this one, and then Z1 is that one in rectangular form. Now we can add them, no? So to add them, it's easy. You just add real parts together. So this plus that. Does it make sense? And that will give us a 3.945 plus, now we can add this part and that part, né? That give us a 3.896I. And you see, this is the final answer. We round off to 3 decimal places. Right, and then let's go on. 2.3.1. We are given that Z is equals to minus 4.5 minus 2I. And we are asked to get the conjugate of Z, né? The conjugate, we put a line like that, right? Let's see. The conjugate of Z, yes. You just put a line on top to show that is the conjugate, né? The real part always stays the same. You just change the sign on the I part, né? So here we have minus 2I, here we must have plus 2I. That is easy, 3 marks, né? The conjugate, you just switch the sign on the I. It was a minus, now it's a plus. Right, that's it. And then now we are asked to multiply 2.3.2. We are asked to multiply the Z by its conjugate, né? Or the Z by its conjugate. Okay, let's do that. So I'm going to say minus 4.5 minus 2I, that is my Z, multiplied by minus 4.5 plus 2I, that is my conjugate. Remember I said, when you multiply the Z and the conjugate, né, just multiply the first term and the first term, the last term and the last term, because we have difference of two squares here. So it's going to be minus 4.5 squared minus 2i squared. Right. 4.5 times 4.5 will give us 20.25. Ne? 2i times 2i will give us 4i squared. Right. Then we're going to have 20.25 minus 4 minus 1. Remember, I squared is minus 1. So when we see I squared, we put minus 1. Then the final answer will be 24.25, because this will be plus 4 to that. And that's it, ladies and gentlemen. So here are key takeaways, right? Always flip the imaginary sign when finding conjugate. The real sign doesn't switch. Number 2, if you are asked to multiply in polar form, you have to multiply the r's and add the angles. And then when you add the complex numbers, you firstly have to convert to polar form. And the polar form, it's a plus bi. And I want to repeat this again as an emphasis. If you're looking for conjugates, just flip the sign on I. That's it. Ne? Keep these tricks in mind and complex numbers will feel simple. Don't forget to like, share, and subscribe to the Say Guru Academy. See you in the next video.